Okay, guys, we're going to start these, and then we'll go over homework at the end of this. This is not as long as the other one. The only difference between 5.8b and 5.9b is that the 5.9b ones have variables in the denominator kind of frequently. But it does allow us to get some other problem types going down. So the theme of these are that these aren't necessarily problems that are work rate. They're not necessarily problems that you haven't seen before, but they are problems that have variables in the denominator, which then creates types of stuff you have. This should be on a blue worksheet that every one of you has, and let's go. So these are back to distance, rate, time problems, stuff we've done. This is going to act as a nice little review of things going into the final exam. Your final review packet does have several of these, and I know, it is. There you go. I have to send it in over winter break to be fixed. It means no computer over winter break. Okay, in any case, Luke cycled 36 miles to the beach. Okay, people on this video is going to hear this awkward pause. So this is the kind of trip that we have, and remember the start of the year? Of course you do. We had a worksheet that at its top told the kinds of trips that you have when you have distance, rate, time problems. You have motion in the same direction, you have motion in the opposite direction, and you have round trip. If you have a round trip, you sometimes can talk about a there and then a back as your two trips. And many of you guys still prefer columns, and columns are more than okay here. You don't necessarily have to do columns, but or tables, I mean, but we'll set up a table on this. And on the way, well, let's kind of do a rate, time, and distance for this. So rate is going to be, I don't like putting rate down, it's just not descriptive enough. We're going to do miles per hour. I'm not going to put MPH either. If I write it as miles over hours, I know that the next one needs to be the number of hours, and then the next one final one needs to be miles. And I know then that the number of hours times the miles per hour is equal to the miles. That's where my setup comes from. That said, he cycled 36 miles to the beach, which means that the way back is, okay, so here and here. On the way back, he cycled 6 miles per hour slower than on the way out. As we read that one more time and read that the question's asking what his rate was returning from the beach, given that the rates are unknown, we can set the variable as one of the rates. I'm going to do this how I probably anticipate many of you would do. We're going to let I'm going to let R for rate equal speed in miles per hour. Now I need to pick which one we're going to do. Am I going to do it to the beach or from the beach? It doesn't matter which, but it's probably going to be quickest, and I anticipate most of you will probably do to the beach, even though it's a little bit more efficient to make it from the beach. If I'm just kind of doing this problem quickly, I'm going to go make it to the beach, which means that we have a statement that that speed is R. Given that speed is R, it says he cycles 6 miles per hour slower on the way back. So that gives you an R and an R minus 6. I want to pause for a minute. I want you to recognize that the question is actually asking for the R minus 6. It's not too taxing on your brains to do a minus 6 at the end, but realize that the question is actually asking for that piece. So when you find R, we're going to subtract 6 from it. Capiche? Yep. You can do R and R plus 6. That's fine too. But it's probably a little it's easier to translate it directly from the problem and then pick up the pieces later. So given all this, with the round trip took 5 hours, I still haven't finished putting in the table. And this is where this can get a little bit tricky, because the round trip took 5 hours. That means, in another way, I could say the total time is 5 hours. So I'm going to stick that right here under this, because that represents a total. The total is 5. Okay, Chase, you with me? Yep. These are the unknown pieces right here. And this is where you guys need to change up your thinking on this. That's time. Time is unknown. I know that rate times time is equal to distance, so what is time equal to?
D over R.
So let's express time as the respective d over r's. We're not filling in the last column as the product of the two. We're filling in the middle column as the quotient of the two of them. D over r makes that distance would be 36 over r, and this would make it 36 over r minus 6. So then my setup should be, just kind of fixing these, my setup should be 36 over r plus 36 over r minus 6 equals 5. Now we can do a least common denominator on this, and get this, I need just a little bit more room. I'll scooch all this up. LCD? So I get 36 times r minus 6 plus 36r equals 5r, r minus 6. Which now means that I have to multiply everything out, which you can do. 36r minus 6 times 36 is 216, plus 36r equals 5r squared minus 30r. If I move everything to the right side, I would get a 5r squared plus 72, so the minus 72 minus 30 is minus 102r plus 216 equals 0. Now we have to split it. And we're going to factor this. 5r and r. I know it has to be a minus and minus. I know that 216, I know it factors into 6 and 36. So we could try to do 5 times one of those minus the other to get to 36. It's not going to work. I want you guys to play around with the numbers for just a minute. And I'm going to pause this while you guys do that. Back to recording this. And I'll say it again. Look at the 36 and think of any number that divides 36. You guys said 3. So I divide 36 by 3 and I get 12. And I'm going to multiply that 3 by the 6 and I get 18. I know 18 times 12 is 216. 18 and 12 are also kind of centric, which is helpful. Then I test. 5 times 12 is 70. 70 plus 18 will not get us to 102. 5 times 18, oh, you can do that. And if you want a quick way to do 5 times 18, take a 2 from the 18 and move it over to the 5. 5 times 18 is the same as 10 times 9. That's 90. 90 plus 12 is going to be 102. So we need to make the 18 times the 5 happen, and the 12 happen by itself. And I get r is equal to 12/5, and r is equal to 18. I'm going to immediately reject one of those two r values. And it's not because 12/5 looks ugly. I think it looks pretty. It's because that when I take 12/5 and I plug it into r minus 6, it'll be a negative number. So that one's out because that would mean that my rate is going to be negative on the way back. And I get bingo, r is equal to 18. But the question did not ask for r. What did it ask for?
R minus 6.
So we can say the return rate is 12 miles per hour. Okay, next we got some more wind problems. But you guys kind of mastered the wind problems last time. So a blimp can go 32 miles against the wind in the same time it takes to go 88 miles with the wind. The speed of the blimp in still air is 30 miles per hour. What's the speed of the wind? So we've got two trips like we did before, and whenever we have wind problems, our two trips are typically like an against the wind and a with the wind. Against and with. And we're going to set up the three scenarios here where I need to put my units down: miles per hour, hours, and miles. Please don't do M for miles. The track person in me would hate that. Yeah. So blimp can go 32 miles against the wind. Here's against the wind, 32 miles. At the same time it takes to go 88 miles with the wind. The speed of the blimp in still air is 30 miles per hour. What's the speed of the wind? I can't put the speed of the wind in the table without defining it as a let statement because it's kind of existing outside of the table. We're going to let W equal speed of wind in miles per hour. If it lets me write. No, I did not switch the marker. There we go. Okay. What's the speed of the blimp in still air is 30? What's against the wind going to be? I like W because wind. And with the wind? There you go. Like before, how do I calculate the number of hours? Yeah. So let's make a note to yourself that time is equal to distance divided by rate. Now, what are the key words that are going to make this actually work here? Because I've got two times here expressed as things. I've got a 32 over 30 minus W, and I have a 32 over 30 plus W. What do I do here? Yeah, how do you know that? Yeah, the two key words are here in the problem. They're buried, but they're present, like right in front of your face, screaming at you, same time. So when it's same time, we're going to put an equals between the two of them and solve.
Isn't 88 over 30?
Oh, it is 88. That ain't bad. I'll put that in a different color. That should be 88. That wouldn't make sense otherwise. Okay, I've had a couple of you guys ask if you can cross multiply with two fractions equal. It's the same math, so I'm more than fine with that. You don't have to state an LCD if you have two fractions, but as soon as you have a plus something else, you need to do a least common denominator. But just to be different here, we do know that if two fractions are equal, their cross products are also equal. So we get 88, 30 minus W. Please do not distribute the 32 and the 88 right now. Don't do it. Because you can make your life simpler. Even before that. Divide by 8. You said LCD. Now just divide both sides by an 8. We're going to get a 4 times a 30 plus W equals an 11 times a 30 minus W. You've made your life simpler. Now distribute 120 plus 4W equals 11 times 30 is 30 plus 300, 330, minus 11W, or 15W is equal to 450. 15 goes into 45 three times, so W would be 30.
Why is it 450?
It shouldn't be 450, it should be 210. So if I'm dividing 15 into 210, I'm not going to do it directly. I'm going to divide both by 3 and get 5W is equal to 70, and then W is equal to 1, 4. That makes better sense. Shouldn't the wind be less than the boat speed? If it's not, then bad things happen. So we can say the wind speed is 14 miles per hour. Okay, last one. And your last notes word problem of the semester. Yeah, last notes word problem. And I think I'm going to say this, yes. Okay, ready for this statement? Your last example problem of new notes of the semester.
You're
This is the last example. Oh, no, don't clap yet. We're not done. I mean, it's not done yet. It's like clapping before the movie starts. I mean, just don't do that. Elizabeth drove the first half of the trip at 36 miles per hour. At what speed should she cover the remaining half in order to average 45 miles per hour for the whole trip? So, I want you guys to write at the top, harmonic mean. We kind of talked about this the other day. And harmonic mean. A harmonic mean, all I want you to realize is that it's not as straightforward as you think you can, because you cannot average rates. You can't do that. You can't average rates. Rates don't work that way. Rates are ratios. Ratios are fractions. You can't add fractions by adding numerators and denominators together. That's just not how this works. So it says she drove the first half of a trip at 36 miles per hour. At what speed should she cover the remaining half in order to average 45? The answer to this is not 54. It would not be 54. I know many of you are thinking that because you're like, well, let's make a progression of 36 to 45, 9 apart from that, 54. That would mean 45 would be in the middle of 54. Now, if I said you have a test grade and that test grade is 36 and then you need to average 45, which you get on your next test to average 45, that would be fine. That would be a simple testing. But with this, these are rates. The problem with harmonic mean and the problem with rates is that rates are affected by how long you are present at that particular rate. For instance, if you go the first half of a trip at 36 miles per hour, you're spending a lot of time doing that 36 miles per hour. A lot of time doing it. Think of it this way. If I did the first half of the trip at 1 mile per hour, there is absolutely no way I could do the remaining half at 45 miles per hour and still reach it at a reasonable time. Like, let's say, okay, let's kind of do this example. Let's say that the first half of the trip from here to a mile away was at 1 mile per hour, and I want to average 45 miles per hour for the whole trip, 2 miles away. Okay, if I average, let's play that example out just for a second, and then we'll kind of get to this. This is 1 mile. And this is 1 mile here. And I'm going to go this way. I'm going to average 1 mile per hour. Well, how long did it take me to go?
An hour.
It took me to go 1 hour to go that far. Now, let's say that for the entire trip, I want to average 45 miles per hour. Okay, so if I go 45 miles per hour for 2 hours, or for 2 miles, okay, we can do this. Time is equal to distance divided by rate. Distance is 2 miles divided by rate is 45. That's 2/45. That means I have to complete this in 2/45 hours. But I've already spent 1 hour going that first half. At that point, it's impossible to make that kind of average. You've already used up all your time. That's one of the problems with harmonic mean. You spend so much time on the first half of this when it's slower that to go faster for the second half, it's not just a matter of like trying to average it out. It's that you have to play into account how much time you spent. So the problem setup is going to be very similar to what we've done. I just need you to have that sense in your head that it's not just a simple matter of averaging, and you cannot average rates. Okay, we're going to set up a table. First half, second half. And this should start to become a little bit more clear to you about why this is happening this way. First half of the trip, rate in miles per hour, we're going to go 36. The second half of the trip, we don't know. So, X. We'll just throw an X down. Now, here's the key thing about this. We have hours and we have miles. The weird thing about this is that it's not going to matter at all how long the trip is. The answer will actually be exactly the same, whether we're going 100 miles or whether we're going 5 miles or 1 mile. It won't matter. So what I'm going to do for this is I'm going to say that the trip is the simplest possible number of miles to have a first half and a second half. 2. We're going to say the whole trip, and I'm just going to put, let's just say, the whole trip is 2 miles. It doesn't actually matter how many miles you have. And if you want to be completely precise, what you say is the trip is 2D miles, because you're going to watch your D's end up canceling, so it won't matter. But 2D would let you have a variable in there, so it just has distance in that. First half then gives me, if it's 2 miles, and then each half is 1 and 1. Okay, now I'm going to slide this down, and we're going to talk about the whole trip as a final column. We want the whole trip to average 45 miles per hour. I don't know how long the whole trip is going to take, but I do know that the whole trip's mileage is how far? 2. Just the number of miles is 2. Now, like before, we're going to set up time is equal to distance divided by rate. So 1/36, 1 over x, and 2 over 45. Do you see how the setup's going to work now? The time it takes to go the first half plus the time it takes to go the second half is equal to the time it takes to go the entire thing. And if you had said that the whole trip is 2D, which makes each of those 1D, the D's can all cancel out. And that's why it didn't matter what distance it was. Sometimes I'll tell people, make it 200 miles, so that this becomes 100 and this becomes 100. But then when you divide both sides by 100, you still get the ratio of 1 to 1 to 2. So it didn't matter how long the distance was, and the simplest is just to make it that. What's your LCD between 36 and 45? Don't overuse your 9. There's 9 in there once. 36 is 9 times 4, and 45 is 9 times 5. So can't we just do 9 times 4 times 5? And that will cover both of them. And if I multiply 36 by 9 times 4 times 5, what do I get? The 9 times 4 goes away. What do I get when I multiply 136 by the LCD? 5. Oh, I should have an x in there too, shouldn't I? So I get 5x plus, now I have to do 9 times 4 times 5. Actually, 4 times 5 is 20. 20 times 9 is 180 equals and then this would be 9 times 5, 8x. X equals 180, x is equal to 60. So she should go 60 miles per hour. Wait. No, we have to do that Ignatian thing where we reflect now. You guys had thought it might be 54 if it had been a linear progression, but it's not. She actually has to go 60 miles per hour to achieve that. That gap is growing greatly. That's what's kind of the harmonic mean concept. Okay, we'll stop there.